Hello everybody, my name is Alex and welcome to part 3 of my GameMaker Basics tutorial series. In this video we are going to focus on player movement. We're going to implement the ability for our player to move in all 4 directions. So we have our sprites, we have our objects, we have our room. When we run our game, it shows us our room with grass and our hero, and right now we can only move 1 pixel to the right whenever we press the right arrow key, and that's it. Completely inadequate, obviously, so let's make that better. So if we look at our hero object, we can see that in the press right key we have this code. One thing I should have done in previous videos is make the text bigger. In the code editor, if you press F8 on your keyboard, everything zooms in. If you press F7, it zooms out. So I'm gonna go ahead and make it really big to make it real easy to read. So right there, you can see that I'm modifying the hero object's X attribute. And as we learned in the last video, when you change an object's X value, you are basically moving it on the x-axis. That means you're moving it horizontally, and when you add to it, you make it go to the right, and if you were subtract to it, you would go to the right. So some of you may be thinking, okay, not a problem, all you gotta do is copy this code, right? Go into the hero and add another trigger, this time going keyboard press left, and then copy the code. Instead of adding, subtract, and if you run the game, if I press to the left, he moves left, and if I press right, he moves right. Awesome, yeah, that totally technically works. It absolutely works. However, what if we want to move more than 1 pixel? We want to move 2 pixels. Okay, well, I just changed it to 2, but that's only in the left direction. Obviously, I want him to move in the same speed both directions, so I have to go to the right trigger and then change that 2. And if I had the ability to move up, then I'd have to go into that trigger event and change that 1 to a 2, and I have to go to all of these different places to change a number, and it can get very confusing. Obviously, it's not confusing right now, but if I had a lot of objects and lots of events, it would get kind of difficult to keep track of all that stuff. So we are not actually going to bother using these key press triggers. It's a lot better idea to instead have all that code in the step event. Like I explained before, the step event is happening constantly. So that's going to allow us to basically check the keyboard state every frame of the game. But more importantly, it allows us to have all the code in one window, which you may not think is a big deal, but it is. The better you organize your code, the more concise it is, the more organized it is, the better it is to write and to edit. So that's what we're gonna do. So we're gonna go ahead and right click on these keyboard events and just flat out delete them. I'm not gonna use them right now. Instead, we're gonna use only the step event. And here, if I were to do X equals X plus 1, for example, and we run the game, as you can see, the hero is moving automatically to the right, as if we were pressing the right arrow key every single frame, right? The game runs at 30 frames per second right now, and therefore every second, the X value is being modified 30 times. Cool. Obviously, we don't want that to happen automatically. We only want it to happen when the keyboard is being pressed. Luckily, GameMaker has a nifty little function called keyboard underscore check, and then what parameter you give it is the key that you actually want to check. And in this case, we want to check the left arrow key, which is basically just VK left. VK, I think, is a virtual keyboard, but that's basically just means the left arrow key. That's what that is. This function, keyboard check, checks that key, and if it's currently being pressed, held down, it's going to return a value, and that value will either be true or false. That's called a Boolean value, and Boolean values can only have 2 values, true or false. And when I say returns a value, it means it's actually, calculating this value, true or false, and then it's going to give us that value. However, we have to store that value so that we can use it later. And as we learned in the previous video, you store values in variables. So we're going to have a variable called left input equals. Therefore, this function happens. It's going to determine a true or false value, and we're going to store it in the left input. And then right here, if we check if left input is true by doing a double equal sign, we are now checking, well, let's do minus because we're doing left. We are now checking for the keyboard, and we're checking if that left input is in fact true, and then we're gonna move, we'll modify the X value. So if we run the game, he shouldn't move, and he's not. However, if we press the left arrow key, now he actually moves to the left, and if I hold it down, he just keeps moving completely out of the screen, and then I can't move him back because I'm not checking for the right key. So obviously, if we were to just copy all this code, and instead of having all this left stuff, we're gonna replace the left with right, VK right, and instead of checking for the left input, we're checking for right input, and instead of minus, plus, we just quickly implemented left and right movement. Left and right. Cool. It's smooth. It stops moving when I stop pressing it. And you may think, okay, well, we are good to go. And we kind of are. We kind of are. I'm going to go ahead and quickly copy all this again to be up. Okay, I added the up and down. And of course, instead of modifying X, we're going to be modifying the Y. And we're checking up and down and moving up and down. So we're going to run the game. And so now we should have all 4 directions: up, down, left, right. Cool. We can even move diagonally, right? Because we can check for 2 keyboard keys at the same time. GameMaker is able to detect multiple keys on the same frame. So we can move diagonal, up and down, and that works. And if that's what you want for your game, then cool. You can go ahead and do and work with that. However, I don't want that. Some of you may recognize this sprite. This sprite is from Dragon Warrior or Dragon Quest, the original for the NES. And in that game, and in lots of old school RPGs, when you pressed right or any direction, you would automatically move a set distance and then stop. And then if you held the key, he would move constantly. But whenever you stop pressing it, you would always stop, on a grid. You would stop on a certain size grid, in all 4 directions. And you may not think much of that. You may not think it's a big deal, but it kind of is. And I want to demonstrate that, right now. But before I can, I have to actually add a new object, because moving is great. However, we need to have a reason to move, and a good reason to move is to avoid stuff. The thing that we are going to avoid is an object rock. So I just created an rock object. Of course, I did that before creating a sprite, which is totally fine. There's no set order on how you create things. But we are going to have to make a sprite called SPR rock. I'm going to go ahead and import that rock, which I already have here. It's a 16 by 16, same size as my grass, same size as my hero. So we have that rock sprite. We're going to associate it to this rock object that we have. Oops, I did collision mask. Same as what you want. There we go. Sprite rock, collision mask should always be same as sprite for now. Not something you have to worry about. And we're pretty much done with the rock. So we can go back into the hero, into a step. And so, well, actually, let's go into the room first. Let's go into the room editor. Double click on room and that'll open the editor. There we go. So let's go ahead and drag in a rock in here. Of course, we made this rock object, but we didn't actually write any code for it. So if we run the game and we, move ourselves to a rock, what's going to happen? Well, absolutely nothing, right? Because we didn't actually code anything about those rocks. What we want the player to do is to, bump into the rock and not actually be able to move into it at all. Basic collision, code or, behavior. So we're going to do if, your X plus 1, or actually, no, my bad. You want to use a function called place meeting. So let's just write that code, that function, place meeting. And what place meeting wants, it's a location. And so we're gonna give it our location, our coordinates of the player, X and Y. That's what we're checking for. And what object are we checking for? Well, we're gonna check for that rock object we just made. So basically this function is gonna return, well, this function is gonna check if at these coordinates, X and Y, is there a rock? And it's gonna return a true false, just like the keyboard check value. So we're gonna go ahead and do if this is true, as in there is a rock here, we're gonna go ahead and let's do X, or let's do image blend. Now what image blend does is it changes the color of your sprite. We're not actually gonna stop the player from movement. We're just demonstrating the ability to collide with a rock. If you change an object's image blend, you're basically changing its color. And what's wrong here? I think we gotta kill that. Your parentheses always have to match. And if this returns false, that's where this else command comes in. If this statement is true, then it's gonna run the first block of code, which is gonna be all the code within these brackets. Otherwise, if this is false, and it's gonna run this code inside these brackets, in which case we're gonna reset its image blend to white. White basically just means that you're resetting the sprite to how it looked when you first loaded the game. So right now, our image blend is technically white. However, if we were to touch a rock, we turn red. That means we're colliding with it, right? We're not actually stopping. However, our player is touching it, and it's modifying our image blend, right, to be red. And when we're not touching it, it's white. So we're just demonstrating that collision is indeed happening. Actually, let's go back into the game. Imagine you're in like a tight tunnel situation. You're trying to move past this rock, right? Let's say you're moving up and I have to move around this rock. Well, if our current movement system is a little too nuanced, like we can move a little bit, and then if we try to move, I bumped into the rock. I didn't want to. What if there's a rock up here? Let's go ahead and demonstrate this a little better. Trust me, all this will make sense. So I'm gonna move this rock over here, and rock over here. The reason why I want to have a set move distance is because, like I said, our movement system is too nuanced, and like squeezing into this thing is gonna be like hard, right? Because like I'm gonna move in, I turned red. I turned red. It's like you gotta really look. It's like almost impossible to get in there. Okay, see there, I did it. That took me like several tries to get in there, right? Like if these were spikes or something and they were actually damaging me, that would be really annoying, right? To force the player to like have to really feather his movement to fit in there without taking damage. So what we want to do is like have our player automatically align to a grid so that when I stop moving, he's automatically going to snap to this little center passage so that I can just move in there freely without worrying about bumping into rocks. Because right now I'm bumping into them real easily because I'm moving one sprite, one pixel at a time. And that's too hard to work with. You're asking too much of the player at that point. Instead, we want to move in increments. And what increments do we want to use? Well, we want to move the same size as our grass. And as you remember, our grass is 16 by 16, and our rock is 16 by 16, and our hero is 16 by 16. Therefore, we want to move in 16 pixel increments. So instead of 1, let's just put a 6 or a 16 in there, and then run our game. This might be a little hard to control because I'm going to be moving fast, but yeah, that's a little too fast. But if you notice, if I feather it, see how I'm perfectly aligned with these rocks horizontally, and if I tap it, my keyboard, see, I'm gonna it's gonna be hard to get in there, but see how I'm always ending up aligned? That's what we want. It's just we're moving too fast, and so I can't control it. But we want to move in 16 pixel increments, basically, so that we can fit through stuff very conveniently and easily. So basically we're gonna have to redo our whole movement. our whole movement system. Instead of just moving very freely, we actually want to restrict our movement. So for starters, let's go ahead and organize our code a little better. So remember in the last video, I talked about comments. Comments are great because they help you organize your code because you can specify. And of course, these are optional, but I like them because I like to put, stuff that helps me organize my code. So get player input is obviously gonna signify that the next couple lines of code is going to do exactly that, get the player input. So we're gonna go ahead and cut these input keyboard check commands and put them all at the top. So now all our control input is at the top. Now we are going to actually check what keys were pressed with these input variables. So we're gonna do check movement keys, or no, actually, never mind. We don't need to do that. We're getting the input up here and that's good enough. Let's go ahead and go into the documentation and look up a function called Lerp, because that's what we're gonna use and that's what's gonna drive our new system. Lerp may be a little confusing at first to understand what's going on, but actually it's very simple. Basically, the Lerp function is going to return a value between a first and second value that you specify, right? So if you specify a 1 and a 5, it's going to return some number, or some decimal number between 1 and 5. You can return a 2, a 3, a 4, or a 5. Now, depending on the third value is what it's going to return. So if I give it a 0.5, that means it's going to return a number right between, in the halfway point between the first and second number. If I give it a 0, it'll basically return the first number. If I give it a 1, it'll return the second number, right? So basically the third number is always going to be from 0 to 1, and it's basically a percentage value between the first two, right? Lerp stands for linear interpolation. And interpolation basically means, a value in between or moving between two values. It may be a little confusing. Go ahead and read the description and these examples, but really, once you use it, it actually makes a lot of sense. So what we want to do is interpolate between two values, between one x value and a second x value. And those two x values are going to be determined by our inputs. So what we're going to do is, for starters, create a bunch of new variable names or a bunch of new variables that we're going to initialize in the heroes create event. So we're going to go into the create event. We don't need those. And we're going to go ahead and paste these that I already have it ready to go. And I'm just going to go over them right here. Tile size is, like I said, the size of all our objects, the grass and the rocks. So that's the increment that we're going to move into. Lerp value is a value that I was talking about earlier, that this number is going to be changing between 0 and 1, and that's going to make our player move smoothly between his old position and his new position. And Lerp delta is how fast we're going to be cycling through this Lerp value, right? 0.1 means that in one frame, he's going to go from 0 to 0.1. And then on the second frame, he's going to go from 0.1 to 0.2, all the way till he gets to 1. If we make this a bigger number, he's going to basically move faster between those 2 points. And the smaller the number, the slower he's going to move. So we're going to do 0.1 for now. Old X is going to represent our old location from where we're starting from. And new X is going to represent the new position that we're going to move to. And as you know, we already know that these left inputs are basically the keyboard inputs that we are checking. Now we're putting them all to false just to initialize them, so that way when the game starts, everything has a value and the game runs smoothly. So we're going to go back into the step event and we're going to start using some of those variables that we just initialized. So we're going to go ahead and remove all this code. And for starters, we only want to move to a new location when we are ready to move. We don't want to move to a new location while we are still moving to a new location, right? We only want to check for the keyboard input if we're not moving, basically. If we're not moving, go ahead and move. But if we are moving, don't look for a new location. So we're going to do a conditional statement. So basically, if our current X has reached the new location, and same with the Y. If our Y and X have made it to our new location, then good. Then you can go ahead and check for a new location via the keyboard commands, right? However, we need to reset our old location to be our current location so that we can, of course, then change that when we get the input. Our lerp value has to be reset to 0 so that we stop moving. Otherwise, the lerp of function is going to continuously keep going, and we're going to move past our location. But we don't want to do that. Once we get to where we need to be, we just stop, don't move, and wait for more commands. So we're going to determine the new location to move to right here. And this is where we're checking the actual keyboard inputs. Maybe I shouldn't have deleted them earlier, because now I have to retype them. So let me retype them real fast. Well, actually, let me go over this very first one because it's going to be a little different. Because when we press left, we're not just going to move left. No, instead, we're going to determine a new location to move to, which means our new X is going to equal something. And what is it going to equal? Well, it's going to equal where we currently are minus that tile size that we determined earlier. That way we move exactly one tile to the left. And we're going to do this for all 4 directions. All right, there you go. If left, go ahead and determine a new location to the left, which is X minus. Right would be X plus. And then if we press up, we're going to change our Y to be Y minus tile size, and down will be Y plus tile size. So that's the input that we're checking. Now, well, let's just leave it like that for now. Of course, that's if we are stopped, if we have made it to our new location. Otherwise, if we're still moving or we've determined a new location, we're going to go ahead and use that lerp command. Well, actually, no, we're not going to use the lerp command. Here, we're going to increase that lerp value. That's what we're going to do. So lerp value is going to be increased by that lerp delta that we initialized. Delta means change. So this is how much we're changing when we are moving. However, we want to add a little condition here. We want to make sure that lerp value never goes past 1. Because if it does, then that means our player is going to be moving further than we want him to. So if lerp value is greater than or equal to 1, go ahead and just set it to 1 so that it never goes past 1 to make sure our player never goes past where we want him to. There we go. So of course we did all this logic, we did all this stuff, but we haven't actually moved the player. Remember, a player or the object is never going to move unless you actually modify his X value. So the X's value, this is where we actually change it, is actually going to be the value that is returned by our lerp function. And remember, the lerp takes 2 values. So we're going to take our old X, and then we're going to give it the new X, and it's going to determine some value in between those two. And the amount that we want is, of course, the lerp value. So that's going to be a number from between 0 and 1. And so now our X has actually been modified. We're going to do the exact same thing, but for the Y, of course. And boom, that should therefore work. So we're going to go ahead and run the game. And so now when I push up, he jiggles. All right. All right, the mistake I made was up here. I put new when it's supposed to be old. We're supposed to reset the old X and Y back to my current XY. So now we're going to run the game. So now when I move up, I move a set distance. See, it's like I'm only tapping it, and yet he moves a full 16 pixels, which is exactly what we want. So now when we want to squeeze through these rocks, it's easy. Boom, each time is easy because I'm moving in exactly the same size as these rocks. So it's not even a question. I don't have to worry about it. Now, of course, we haven't actually written any collision code for the rock because we deleted it. However, you can see that I'm right in between with no effort. I don't have to worry about bumping into things accidentally. However, yeah, let's go ahead and add that collision. We can't do it like before because our movement system is pretty different. However, we're still going to use that place meeting. We're just going to use it differently. So this is where we're going to have our collision code. So we want to write, of course, a comment letting us know that check if new location basically collides with the rock. So what do we want to do if the new location is where a rock is? Well, don't go there. If the new location is where a rock is, then just don't disregard this new location, right? So if place meeting, no capital, there we go. So if the new X and my current Y is colliding with a rock, we'll go ahead and disregard this new location. We can just reset that new X to just go back to our old X, right? That's why we have the old X. Well, another reason to have the old X. And we want to just copy that same code, but this time for the Y. You can't really, you can check for both X and Y in one line of code, but it can lead to lots of bugs. So the safe way is to just do two separate checks, one for the X and one for the Y. Checking them both at the same time can lead to some shenanigans. So that's why we have two lines, one for X, one for Y. Should be, this should be, X, Y, new X, Y, X, new Y, object rock, new old. Yep, that should be fine. So now we're going to run our game. And so now it's not letting me move into the rock. Why? Because when I press right, my new location is inside the rock. And if it's inside the rock, that means it's colliding, which means my new X then gets reverted to my old X. So I basically don't move. Same with down. If I move up, I can't. If I move left, I can't. I can move through. And I don't have to worry about finessing my movement because I'm always on the grid. I'm always moving in 16 pixel increments. And so now my movement is buttery smooth. I can tiptoe around these rocks like a pro. Look at that. Wow. Awesome. I know that the movement code was a little complex. This tutorial video jumped up a little bit in difficulty, but trust me, this movement system is a lot better, a lot more robust, and for the type of game that we're making, it's going to be perfect, and it's going to prevent lots of problems in the future. So we are done with this video. If you found it helpful and useful, go ahead and hit that like button. Until then, I will see you next week for video number 4. Thank you.